Hey everybody, Paul here for our video for the week. We're going to start by looking at a probability question that we've seen a bunch of times and thought a lot about, and then we're going to look at a slightly different way of thinking of probability, and we're going to do some comparison, and we're going to kind of learn a new way that we can answer probability questions or think about a probability scenario. Okay, let's start with this one, right? So you have a bag of marbles with five red, three green, and two blue. Or visually, you have this bag of marbles. You close your eyes and pull one marble out. What is the probability that you would pull out a red marble? What is P red? So we've done this kind of probability question a bunch of times. We know that we're going to use this idea that the probability that you get a certain outcome is the number of ways an outcome can occur over the total number of possible outcomes. In this case, because we're trying to find red, we notice that there are five red marbles. That would be the number of ways an outcome can occur. And there are, I believe, 10 total. 5, 3, and 2 would be 10, and that would be the total number of possible outcomes. So in this case, the probability that you would draw a red marble would equal 5 over 10, right? That's our probability. So we have 5 red marbles, 10 total ways that they can occur. Probability is 5 over 10. We've done this a bunch of times. We're looking at outcomes. We're looking at the number of ways an outcome can occur and the total number of outcomes. But not all scenarios work this way, both in math class, but also in real life. Sometimes maybe you don't know the total number of possible outcomes of something. Let me give you an example. You have a bag with red, blue, and green marbles, but you don't know how many of each there are. So not only do you not know how many red marbles there are, you don't know how many total marbles there are, right? And I guess the idea is you're not supposed to look at the bag and count or whatnot. So what can you do? Well, uh, 10 other people have pulled marbles out of the bag. Four pulled out red marbles, five pulled out a blue, and one pulled out a green. So I guess the idea is other people are like doing this game where they pull a marble out and they go, oh, I got red. What is the probability of red? So how can we answer this question, right? When we have this bag, but we don't know how many marbles are in it. We cannot use this formula because we don't know the number of red marbles and we don't know the total number of marbles in the bag. But we do have some data, right? People have been pulling marbles out and kind of conducting a little experiment, right? 10 other people have gone before you. And so now we're going to think about probability not about knowing total outcomes and stuff like that. We're going to think of it from like an experiment standpoint. And we're going to think of it this way. The probability that you get some outcome is the number of times an outcome occurred. So like in the past, divided by the total number of trials. Now, what's a trial? Well, luckily we have that definition. Trial is an event, so we're still thinking of events that has occurred in the past where the outcome is known. So the idea for this is you have this bag, you don't know how many marbles are in there, but you have this data that four people pulled out red, five pulled out blue, and one pulled out green. So to answer this probability question, we would say the probability that you get a red marble would be the number of times that a red marble was pulled out of the bag, which was four, right? Divided by the total number of times marbles were drawn. That's the trials, right? A trial here was pulling a marble out of the bag, and that was 10. So this is going to be probability of red is 4 out of 10. We're not looking inside the bag, we're looking at what has happened in the past. And while both of these probabilities are fractions and both of them have to do with red marbles, they're actually very, very different in nature. There are two different types of probability, right? Or two kinds of probability, right? And we've named these things and they have different characteristics and different formulas. So let's do a quick comparison, right? So the first kind is called theoretical probability. It is a probability based on what we think will happen, looking at a situation. On the flip side of that is experimental probability, right? It is a probability based on things that have happened in the past, okay? So theoretical probability looks at total outcomes. Oh, that bag has 20 marbles in it, so that your denominator will be 20. Experimental doesn't look at total outcomes. It looks at the trials. It looks at the number of times that you did the thing. Oh, 15 people have pulled a marble out of the bag. That will be the denominator, the bottom number of your probability, right? Experimental probability uses past data. It looks at what has happened in the past to make predictions. Theoretical probability does not. It just looks at the scenario, right? It doesn't say, oh, if people have done this in the past, it doesn't worry about that, right? And to be really clear, theoretical probability is what we've done so far. Every probability question we have done so far this year has been theoretical, but experimental is what we're going to do, okay? Now, I said that there are two different formulas. You've seen both of them, but just to show it, right? For theoretical probability, the probability that you get some certain outcome is the number of ways an outcome can occur over the total number of possible outcomes. For experimental, right, it's the number of times the outcome already occurred over the total number of trials, the total number of times that we did something. Let's look at two examples of experimental, and then we'll look at some comparison scenarios, okay? So here's an example. So LeBron James is practicing free throws. Out of the last 20 shots he took, he made 17. To visualize that, we have this little basketball goal. What is the probability he makes a free throw? Or what's the chance that this basketball goes in the hoop? So this would be an experimental probability because we're looking at past data, past information of the last 20 shots, right? So we're going to think of it from this standpoint, number of times an outcome occurred over the total number of trials. Well, in this case, right, because we want to actually make the free throw, right, we say how many times has he made a free throw? Well, he made 17 free throws. And what was the total? It was 20. So the probability that he makes a free throw based on what's happened in the past is 17 out of 20. Or I think it's about 85% if you want to think that way. I've heard he's a good basketball player, so I'm assuming he's going to probably make it a good number of the time, right? We're counting still. We're looking at totals, but we're not looking at make it or miss it, right? There's only two possible outcomes. He makes the free throw or he misses it. We're looking at what's happened in the past, okay? Here's another example. Nicole has 4 different options for breakfast. She has cereal, toast, oatmeal, Pop-Tarts. Over the last month, she has chosen cereal 6 times, toast 8 times, and Pop-Tarts 15 times. What is the probability that she chooses cereal? So if we didn't have this past data, if we only had this part of the scenario, and it said, what is P cereal? We would probably say, oh, well, it's 1 out of 4, because there's 4 options, right? And one of them is cereal. But we see over the past that Nicole has not just been randomly choosing stuff, right? She has this preference. So she's chosen cereal 6 times, right? What we're really trying to answer, right, is she has this breakfast plate and what's going to go on that plate, right? So we're going to use this newer formula for experimental, right? The probability in this case of cereal should be, well, cereal has occurred 6 times. And how many trials were there? Well, let's see. She ate cereal 6 times, toast 8 times, and Pop-Tarts 15 times. So the total would be the sum 6 plus 8 plus 15, which is 29, right? We have 29 trials in this case. And of those 29, she chose cereal 6 of them. The probability of cereal would be 6 out of 29. Something worth noticing, in this scenario, right, Nicole has chosen oatmeal 0 times. So even though it is a possible option, right, I guess Nicole just really never wants to eat oatmeal, right? The probability of oatmeal, even though it is a possible outcome, is 0 out of 29. Okay? It's useful thinking about this as we have this past data and it can help us know what we think will happen in the future. Okay? Now, how can we tell if a scenario is experimental or theoretical? Well, let's look at some side-by-side cases, okay? Here's the one we just looked at. Nicole has 4 different options for breakfast, right? Cereal, toast, oatmeal, or Pop-Tarts. And then we have this past data, right? So I'm highlighting the yellow part. All of that is data. It's info from the past, right? We know what has happened in the past. If you have data, if you have things from the past like that, if there's like past tense for that kind of stuff, it is very often going to be experimental probability. Okay? Now let's look at the flip side, right? Nicole has 4 different options for breakfast: cereal, toast, oatmeal, or Pop-Tarts. Every morning she randomly picks one of the options. Well, the idea behind this, if she's randomly picking an option, right, then it doesn't matter what happened in the past. She's just like, oh, I'll just choose that today. So all 4 of them are equally likely, right? So we don't actually care about what's happened in the past. We say, oh, well, there are 4 total outcomes. And of those 4, one of them is oatmeal. And so now P oatmeal would be 1 out of 4. And that is our theoretical probability. And that's theoretical thinking, right? Here's another example. Let's read through these. And then you're going to decide whether they're experimental or theoretical. You and your friend play rock, paper, scissors. Your friend always throws a random throw. What is the probability of rock? Here's the other one. You and your friend play rock, paper, scissors. 9 of the last 10 throws for your friend were rock. What is the probability of rock? I'm going to go ahead and just fix the tiny little typo right there. Your friend, okay? What do we think? Which one of these is experimental? Which one is theoretical? Well, let's see, right? So this one talks about having a random throw. This one talks about 9 out of the last 10. So this one appears to be past tense, right? Things that happened in the past. You can see it's not that hard to realize that this one is going to be theoretical, right? And this one's going to be experimental, right? Just to check, what would actually be probability of rock in this case, right? Well, 9 of the last 10 throws were rock, so the probability of rock, I think, should be 9 out of 10. And in this case, if your friend's throwing random throws, well, there's 3 total possible outcomes. So now the probability of rock should be 1 out of 3. Right? So over here, your friend really likes rock. I mean, rock kind of beats everything, right? Except for paper. And over here, your friend's just like, whatever. It's just whatever comes to me, okay? So it's like a different way of thinking about the likelihood of something occurring, okay? I hope that makes sense. And this is a slightly long video, but it's the only one for the week. Hope everyone is doing really well. I miss all of you, and I will hopefully see you soon. Boosh.